All right, recall that in the previous video that I reviewed sales tax and coupons and incorporated it into our Algebra 2 unit as to when would we ever use this. Well, we would use this as a scale factor at an exponential level. So I want to strengthen your knowledge of how to be flexible between a scale factor and a scale rate. So remember that a scale factor is what you multiply by your base, in other words, your principal or your original amount. And it reflects a certain percentage of growth or a certain percentage of decay. So if your scale factor is bigger than 1, think about it. If you were to multiply a number by something bigger than 1, it's going to grow. So if the scale factor is greater than 1, then your scale factor is actually a growth factor, which has a percentage of a growth rate. If your scale factor is between 0 and 1, that means that you're multiplying by something and it's going to get smaller. So if you multiply something by, let's just say 50%, it's going to shrink by cutting it in half. So if the scale factor is between 0 and 1, then it's what's called a decay factor with a decay rate. Okay, so now that's out of the way, today's just going to be 24 questions on, the first 12 is going to be, you are given a scale rate, either a percentage of growth or a percentage of decay. What would the scale factor be? So for instance, remember that we compare it to 1. So 15% growth. Does growth add to 1 or subtract to 1? I should rephrase that. Subtract from 1 or grow by adding by 1? Yeah, so what we do is we basically say, hey, 1 plus the decimal, 15%, is 0.15. So my scale factor is 1.15. So if something is growing by 15%, I would multiply that original amount by 1.15 to make my life so much easier. However, if something were to decay, in other words, shrink by 15%, think of this like a coupon. If something is 15% off, what percentage of the original price do you pay? Well, I'm going to subtract it from 1. So specifically, 1 minus 15% as a decimal, that'd be 0.15. 15% off would be 85% of the original price. So my scale factor that reflects 15% decay rate would be 0.85. Okay? See if you can do number 3 and number 4. What is the scale factor if you know that it is growing by 7%? What is the scale factor if it is decaying by 7%? Okay, so let's take a look at this one. If it's growing, if it's a percentage of growth, we take 1 plus the decimal. 7% as a decimal, remember, hundredths, 7 hundredths, 0.07. In other words, it is going to grow, so we multiply it by 1.07. However, if it is going to decay by 7%, we would take the original scale factor of 100%, or 1, and we are subtracting 7%. Let's just say in this hypothetical world that we have a 7% off coupon. Why not? It's my world. 7% off. Take it or leave it. 7% off 100%, you would pay 93% of the original price. So my scale factor would be 0.93. And that's pretty much all it is. You just apply it at an exponential rate. So see if you can do these, or before I move on, you can try these on your own. What happens if it grows by 38%? And what happens if it decays by 38%? Again, if it grows by 38%, I take my scale factor of 1, and I'm going to add that 38% as a decimal. So that'd be 1 plus 0.38, or I just multiply it by 1.38. So that's my scale factor. But if something were to decay by 38%, in other words, let's say in my world, because it's my world, I have a coupon that is worth 38% off. So I have 1 minus 38% as a decimal, that'd be 0.38. If I take 38% off of the original, that means that I'm only paying 62%. So that'd be 1 minus 0.38, that'd be 0.62. So that would be my scale factor. Okay. This one's a little bit tricky because this is a decimal in the percent, which you'll see in car payments. You'll see like an annual percentage rate of 2.7%. So you need to be flexible because those apply at an exponential rate. So for instance, what does it mean for the scale factor if it is growing by 2.7%? So once again, if it's growing, you take the 1, you add the 2.7% as a decimal. So what calms me down is to look at this like a whole number. If this is 2%, then I would write this as 0.02. And anything after that just applies for the decimal. So 2% would be 0.02. Tack on the 7, and that is 2.7% as a decimal. So if I were to add these, I would get 1.027 as my scale factor. If I were to show something growing by 2.7%, I would multiply it by 1.027. Okay. However, if something were to decay at a rate of 2.7% per day, or 2.7% per week, or 2.7% per year, what would my scale factor actually be? I would take my original 100% and subtract it by that 2.7% as a decimal. So that'd be 0.027. And so I pull out my calculator. Well, I'm just going to use mental math really quick. So a 2% decay would be a 98% retention. So I would only, let's just say in this coupon example, I have a 2.7% off coupon. So let's just round it and say that 2% off would be 98% of the original price. But then if I lose this, then that would be 97.3. But I'm just going to double check with the calculator. 1 minus 0.027. So that'd be 0.973. I would pay 97.3% of the original price. So that would be my scale factor. Okay, turn the page. Decimal in the percent. What does it mean for the scale factor if it is 23.1% growth? Okay, so I take my 1, and I'm going to add 0. If this was 23%, that'd be 0.23. But because it's 23.1%, I'm going to tack on the 1 in the thousandth place. So 1 plus 0.231, that scale factor is going to be 1.231. Right? Just to give a little bit of variety, what happens if something is decaying by a rate of 48.6% every month? Well, let's find out. So I would take my 1, and I would subtract it. Remember that 48% would be 0.48. but because it's 48.6%, we're going to tack on that 6. So, my paper's falling. So then I get out my calculator. 1 minus 0.486. My scale factor is going to be 0.514. So it retains 51.4% of its original value is what this problem is trying to say. 1 second, let me just get my laptop really quick. Let me just put my stand there below. Okay, thank you. Sorry, I just need to refresh something. Okay, moving on. Problem number 11. This one's a little bit tricky, and this one is a common misconception. What does it mean if something is growing at a rate of 100%? So what does 100% growth mean as a scale factor? If you said that your scale factor is 1, think about it. If you multiply something by 1, does it grow or decay or... No, it stays exactly the same. So when people say, oh, it's 100% growth, so your original amount is 1. If I were to write 100% as a decimal, I mean, I could do 1, but, let's see it like this. I'm not really changing. I'm not trying to confuse you. 1 plus 1 is 2. So if this is your, this is your aha moment, when something doubles, and I want to make this 100% clear, 100% clear about 100% growth. I want to make this crystal clear. It's a pet peeve of mine when people say it's growing at 200%, so it's doubling in size. No, technically, when something is doubling, it has a 100% growth rate. So it's growing by its original amount. It's literally a virtual copy of itself. So it's 100% growth. Okay? All right. What happens if it's a decay rate of 95%? What's my scale factor going to be? That's going to be 1 minus, and 95% decay, so that'd be 1 minus 0.95. That'd be a phenomenal coupon. I'd love to go shopping if something was 95% off. If it's 95% off, what remains? Only 5% of its original value. So my scale factor for a 95% off coupon, because it's my world, would be a scale factor of 5%. A scale factor of 0.05, a scale rate of 0.0, yeah, exactly. So the scale factor is 0.05 because you only pay 5% of the original value. Okay, now for the next 12 problems, we're going to go in reverse. This time, I give you the scale factor. What does the scale factor tell you about the scale rate? Growth or decay? Okay, so let's take a look at this. Is the scale factor bigger than 1 or between 0 and 1? So we look at this and go, okay, 1.25 minus 1 would be 0.25. So what remains is a 25% growth. Okay, this is a growth factor because this is a scale factor bigger than 1. Okay, 0.95. Is this scale factor between 0 and 1 or bigger than 1? It is between 0 and 1. So that tells me that scale factor is actually a decay factor. Let's figure out the decay rate now. So what I do to figure that out is I take 1 and I subtract 0.95, and that leaves me with 0.05. So because the scale factor is between 0 and 1. It's going to shrink whenever I multiply something by it. So it's decay. Therefore, this is a 5% decay rate. It's shrinking by 5% every unit of time. Okay, number 15 and number 16. See if you can figure out the scale rates for the scale factors of 1.03 and 0.82. Okay, so first things first, 1.03, that's bigger than 1, so it's going to grow. But let's figure out how much. 1.03 minus the scale factor of 1 by default. That would leave me with 0.03. And because that scale factor is bigger than 1, it's going to grow. So this tells me that this is a 3% growth rate. Okay. Number 16, 0.82. Well, that's a number between 0 and 1. So what that tells me is anytime I multiply by something, anytime I multiply by 0.82, my original amount is going to shrink or decay. So I'm going to do 1 minus 0.82. And to complete 82% plus what is 100%, that's going to be 0.18. Or that means that 0.82 has an 18% decay rate. So to tell me that something is losing its value 18% every unit of time, my scale factor would be 0.82. All right. Number 17, 1.4. Number 18, 0.7. What are my percentages of growth or decay for 1.4 and 0.7? So I'm a two-digit kind of guy. So even though it's not exactly the most proper thing to do to add zeros, I like doing that. I like adding a zero. So I'm going to put this in dots. I like double digits because they make it so much clearer. So imagine this extra 0, so 1.40. So it's bigger than 1, which tells me that it's growing. 1.40 minus 1 would be 0.40. There's no crime, even though, you know, a lot of calculators will leave it as 0.4, but I like you to understand this. So what this means is that it is growing at 40% per unit. So it's a 40% growth rate. Number 18, 0.7. Once again, I like double digits. My pen punch. There we go. So I like to put a little 0 right there. There's a little ghost 0. There we go. Not dark enough. Okay, I'll make it a little bit darker. There we go. Much better. If it makes you feel better to put that 0, be my guest. I like it. So remember that the scale factor is between 0 and 1. What that means is that it's going to decay. Let's figure out how much. So if I take 1 and I subtract 0.70 in there, what this tells me is it retains 70% or what percent off. So that'd be 0.30, which tells me that it has a 0.70 has a 30% decay rate. Okay. 2 more problems and then we'll call it a day. Actually, oh, wait. Yeah, there's a backside to this. I apologize. Oh, we're going up to 24. Number 19. 0.724. Well, I'm going to subtract 1 minus 0.724. So my scale factor is between 0 and 1, so it's going to decay. Specifically, 1 minus 0.724 is going to give me 0.276. So therefore, that is a 27.6% decay rate. Number 20. My scale factor is 1.0875. Is that a scale factor of growth or decay? Well, it's bigger than 1, so it's a scale factor of growth. So 1.0875 minus 1. So that's going to be 0.0875. But remember that the scale factor is bigger than 1, so that's got to grow. Specifically, 2 digits to the right, and tack on the 7.5, so that's an 8.75% growth rate. Okay, turn the page. Just like I said. What happens if your scale factor is 2? Not 2 point something, but just 2. Well, it's bigger than 1. So I'm going to take the scale factor of 2 and just do 2 minus 1, or 1. And you know what? Just tack on some decimal places right there. If your scale factor is 2, that means that it has 100% growth. So by that logic, what's a scale factor of 3? Well, it's bigger than 1, and I hate to burst your bubble, but a scale factor of 3 does not mean it's 300% growth. Because remember, you got to compare it to the original scale factor of 1. 3 minus 1 gives me 2, or 2.00 if that makes life easier for you. So specifically, that when something triples in size, it has a 200% growth rate. And I know I'm being nitpicky, but it's the truth. So tripling in size means that it grew by 200%. 2 more, and then we'll call it a day. 1.01 versus 0.01. What's the difference? 1.01 is bigger than 1. So I'm going to do 1.01 minus 1, which is going to leave me with 0.01. Since it's bigger than 1, that is a growth of 1%. Not very much. But it's still something. It's going to grow. Right. And number 24, 0.01. Is that between 0 and 1 or bigger than 1? We subtract 1 minus 0.01, and that would leave me with 0.99. So if something has a scale factor of 0.01, that means that it is decaying at 99% per time unit. All right. Next week, we're going to be doing word problems with exponential functions. Have a good day, guys.